Okay, hello everyone. Good morning, good afternoon, good evening. Welcome to the third session of our study together on Pandas, Python Pandas. So last week we finished the first module actually. So I was planning to deliver that module in one session, but we were able to finish it in two sessions. From last week, those who participated last week, when you receive emails, I'm hoping that you guys receive the links to the recordings of the first two sessions. I already shared the material with you last time, and then I put the file that we did. So this file that we studied together, I put this file into that folder. Again, I'm going to share the link to that folder one more time in case you lost it. Before we start today's session, which is going to be about how we can deal with missing values, that's going to be the first topic. And then again, if we have time, we're going to spend some time on how we can work with strings using pandas and then regular expressions, which might be very confusing at first for those of us who are learning the first time about them. And then hopefully next time we are going to begin working on merging data frames and then grouping them by conditions based on by some conditions. But before we start with this with today's session, remember I hope if you guys went through the last two sessions carefully, now you guys are an expert on how you can slice data frames using either indices or ordered index numbers, right? So we spent some time on them. And then we also talked about how we can set index, how we can re-index. So that's why I put this screen, this file on the screen. So you can set index, whichever column you want, you can set that column as an index. That's for that we are using set index. And then if you like, you can go back to the default indices by saying reset index. When you say reset index, the column that you set as index moves back into data frame, and then you receive the default index values, which are 0, 1, 2, 3. And then if you like, you can re-index your data frame. In that case, remember when you are re-indexing, the indices that you assign are going to be reordered, right? Reordered based on the index values of data frame that already comes with. So for example, in this case, our data frame has A, C, and D as index values. What I'd say is I'm creating another data frame, df2, and then for this new data frame, I am assigning 4 index values, A, B, C, D. So out of these 4 index values, B is not included in the original data frame, df. So the new data frame that I create by re-indexing is going to take the index values from the original data frame because I'm re-indexing the original data frame. But the index value that is missing from the original data frame, which is B, as you see, B is not here, and B is here in the new data frame, df2, I'm assigning NaN values to all the columns in that row corresponding to that index, which is missing from the original data frame. So please make sure that we understand the differences between the set index, reset index here, set index, reset index, and then re-index. So we're going to be using them. And then another thing I want to remind you, I think that this was one of the things that happens occasionally when you deal with data frames, when you first start cleaning up your data sets, is this error here. So let me run this data frame one more time. So where is that? Where is the data frame? Just one second. Let me run this data frame. Yeah, here. So let me run it. So this is our data frame, and then PD is not defined. Okay, again, I already shared this folder, I'm sorry, file with you, and then MP also. Okay, so this is our original data frame. We have 4 columns and then 4 rows. The rows are corresponding to state names, and then column names are 1, 2, 3, 4. Okay, so let me show you that example. We actually finished with that example last time. So what I'm trying to do here is, let me see, which was the, I'm trying to see. what was the error that we were receiving? I'm just trying to remember the error. So we fixed an error here. So let's see. I'm trying to create an error now. So let's see. So df. Okay. So from df, what I want to do is, so this is my df. So what I want to do is I want to select this third column. And then for this third column, the first column value is supposed to be 5. I'm sorry, the second column value is so from all the columns, from all the rows, I'm going to select the row where the second column value is going to be equal to 5. Okay. From all the rows, I'm going to select the rows where the second column value is going to be equal to 5. Okay. So that's what I'm trying to do. And then from that row, I want to select the column name with index value 3. So that's what I want to do. All right. But I'm trying to remember if the last time I was talking about some common error we were doing. So let's see if I can remember that. Okay, let's see if I can remember that. So let's go this way. Okay, df.iloc. Oh, by the way, Dr. Bada, I saw you, just see you are here. But do you have anything to remind us, anything to say? So I forgot that you were here. So I just started talking about the material. Okay. So if yeah. All right. So let's see. So df iloc okay 1 equals 5. Sorry. So equals 5. Okay, let's see what's going to happen when I run this. Iloc. So what I just did is from this data frame, I chose the row or rows. There is only one row in this case, where the second column of that row has the value of 5. Okay. Now from this row, I want to choose the third column. That's what I want to do. So let's see if this will work. Okay. From this column, from this row, I want to filter this row for the third column. Oh, it worked. It worked. So I was trying to show you one error that I happened to see from time to time, but I couldn't recreate the error. So it was something else then. Okay. When I remember, I'm gonna let you guys know. So there was an error that we were seeing last time, and then we fixed it, but now I don't remember what was the error. Anyways, so sorry about that. So this is what we wanted to do last time, and then it works this way or this way. But there was one thing that I wanted to share with you, but I couldn't remember what the error was. Hopefully I will remember. Maybe during the break time, I'm going to fix this and then remember the error. Okay, now if you like, let's move to the next topic. Okay, so this is what we did last time. I'm gonna move to the next topic. So module 3, all right? So I'm gonna do data cleaning this time. So you don't need any file. I'm just going to just to write things from scratch. If there is anything long, I'm going to share it from the chat. Okay, so you can just copy it. Okay, so let's import numpy as MP, import pandas as PD. Okay, so let's import these two libraries first, and then everything will follow. So we are going to talk about how we can handle missing values. Okay, so this time we are going to have a break in at 10:50. All right, we're going to have a break at 10:50. So we're going to have 10 minutes break, and then we're going to get started at 11 one more time. All right. So let's say there is this series. Again, remember, we have series. Series are data frames are composed of series. Series are like arrays, but they come with some functionalities, right? Negative 3.5. I have this NP, NaN, N0. So let's see how this series looks like. Okay. And then this is capital S. Now let's assign this to a data called float data. Okay, and then let me print this data on the screen. And then let me add some cells and then make this a little bit bigger so that you can see it comfortably. Okay. All right. So first of all, I would like to see which one of these values are indicating missing values. This NaN, not a number, NP-NaN. So it is a missing value. It is indicating there is a missing value. I just want to see which of these 4 entries is actually missing. So float, this is the name of the series. All I have to do is I'm going to use isNA method. Okay, so again, this is another mistake I see from time to time. We forget to open and close the parentheses when you run this way. It's just going to give you some information that this is a method. It is a method. Sometimes it doesn't even give you any result. Here we saw some result, but sometimes it doesn't even give you a result. It just says this is a method. So don't be surprised. I see from time to time we forget opening and closing the parentheses. So when I run this, now it is giving me a Boolean array, which is indicating if there is a missing value, the Boolean value is going to be true. Otherwise, the Boolean value is going to be false. Okay, so I see that the missing value is the 3rd element because I get the value true. Okay, so this is just an intro to how we can detect missing values in a series. Now let's talk about if there are any other types of missing values. For example, I'm creating another series. Okay, and then inside the series, let's say I have A, B, 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 okay, comma, NP, NaN. We know that this is a missing value, comma, and there is another keyword we are using, none. So none is nothing, okay, nothing, but let's see how it is going to be perceived here. So DDD, all right. So let's call this time it is a string data. So let's see how string data looks like. Earlier it was a float data. Now this is string data. So here how it's looked like. So here is series of characters. Again, another set of characters, NaN and none. Okay. So now I'm just curious if we are going to be able to see these two guys as missing values. So that's what I'm curious about. String data dot isNA. So again, the first one is not missing. The second and third ones are missing values. The fourth one is missing. Okay, so now we just ran isNA on float values as well as on string values. NP, NaN, and none is working for both series of string values or float numbers. Okay, so next thing is I'm going to create another. Let's do this one too. Another series. So again, this time I'm gonna have 2 integers and none, okay? And then I'm gonna say, but the type is float. 64. Okay. So let's see how float data looks like. Oh, it's 2, okay? Okay, so again, even though I put 1, 2 here, because data type is float, I see that my data, my series, the elements of my series are actually taken as float numbers, 1.0, 2.0, and none is turned into, is again NaN. So here you see here, NaN is NaN. So Here, none is taking as none. Here, none, when I turn none into data type float, it turned into NaN. Okay, so that's something that, again, it's a detail, but let's keep that in mind. Okay, another thing, let's see. Now, what I want to do is I would like to drop if there are any missing values. Okay, so let's say my data is, okay, 1 and 3.5, and another NaN and 7. Okay, so this is my data. Let's just print data on the screen. All right. Okay, perfect. So very simple. Now what I want to do is, so now we know we are an expert on that, right? So which ones are missing? So I can see which ones are missing. All right. So can I use this Boolean array? Can I put this Boolean array into, using this Boolean array, can I filter out, say, non-missing values? Let's see. Data, if I do this, let's see what's going to happen. Data dot is an A. So remember, this data dot is an A is creating a Boolean array. In this Boolean array, true indicates missing value, false indicates non-missing value. If I use this Boolean array as it is, what I'm going to see is I'm only going to see the missing rows with missing values. Okay, that's what I'm seeing. So can I do this? What if I put a tilde in front of that? So if I put a tilde in front of data is an A, what I'm going to do is I'm going to be converting falses into true and trues into false, right? That's what's happening. So then if I put tilde in front of data is an A, actually now tilde is an A is actually giving me true values for non-missing values. Then I'm going to be selecting or filtering out non-missing values. Okay. Another thing I can do is, rather than doing this, I like doing this way because I have control over which ones I'm dropping. So, but I'm sorry, here. Another thing I can do is data, I can drop all missing values from my data. Okay, so here again, I drop any not a number, so I drop them, right? But again, be careful that your data, original data, is still the same. It didn't change. Okay, it's still the same. All right. So then what you can do is you can say data 2 is equal to this. And then now data 2 is the data without any missing values. All right. So let's continue with missing values. This time we're going to work on a data frame. And let me see if, could you put a link to the notebook, please, where you'll put this? Sorry. So again, this notebook is, there is nothing. So we just populate the notebook as we speak, right? So I'm just typing the code as we speak. So there is nothing here. I'm gonna share I already put the file from last week into the folder. I'm gonna share that folder in a minute. Okay, please allow me time during the break time. I'm gonna share the link to that folder one more time. Can we use not NA as well? Not NA as well. So let's see. Data dot not NA. I think we can use it. So not NA is telling us which ones are not NA. So again, rather than using tilde is NA, we can also use thank you. We can also use this data dot not NA. Again, I'm selecting the I'm filtering out the missing values, right? Yeah, thank you. Okay, let's continue. So this time I'm going to create a data frame. Data frame. So in this data frame, again, I have the array of numbers 1, 6.5, and 3. Okay, so if I just do this, it's going to give me one column of data frame. The default column name is 0. Default indices of the rows are 0, 1, 2. We know that now, right? So let's create another column. Let's say this is 1, and this is NPNAN. NPNAN. So let's see how it's gonna look like. Now this became, you see, this became the index values of my rows. No, I don't want that. I want to create 2 columns. So that's why I'm gonna put these 2 lists into another list. Now I have two rows. The first row is 1, 6.53. The second row is 1, NPNAN, NPNAN. So this outer bracket, right, is indicating that the first list is the first row, the second list is the second row. Okay. Now let's, if you like, let's get another row. These are all, this is also, let me just copy this, please do so. Okay, now I have 3 columns. So let me go to the next line and then one more, okay? Perfect. Okay, so this is how my data set looks like. So let's see. I have some missing values in the second row. I have all missing values in the third row. I have one missing value in the last row, and the first row doesn't have any missing values. So if I take my data, so let's call this data, okay, or let's call this df1, so that it's not going to be mixed up with the previous one. So df1. If I take my df1 and then say drop NA. So basically, let's remember how df1 looked like. So df1, this is how it looks like. So when I say drop NA, it is dropping all the rows with at least one missing value. So the second row has 2 missing values, it is dropped. The third row has 3 missing values, it is dropped. The last row has 1 missing value and it is dropped. Okay, so we have only one row which doesn't have any missing values. So another way to drop missing value, all the rows with any number of with missing values. Here, let's see, drop NA. Now I'm changing the condition. So if I say how any, let's see what happens. These two are doing the same. So as you see, the default condition for dropping the missing values is any. Means if any of the rows has at least one missing value, drop it. That's what it means. But I'm going to change this any to all. Now let's see what happens. What happens is I kept the first 3 rows. I kept the first 2 and last row. The third row is dropped because it says all. Drop any row with all missing values. So that's what it is. Okay, so now we have some idea about how many, what is that, missing values, how we can drop missing values based on some conditions. So I can do another trick here. What I can say is I can put a threshold. Again, remember, this is my original data set, right? Data frame. I'm going to say drop any rows with at most, let's say, so with at most up to 2 missing values, right? So this is what I'm going to do. So drop any rows with at least 2 missing values. Let's see. I hope this is the way. Let's see what happens. Yeah. So when I say threshold 2, I'm going to be dropping any rows with at least 2 missing values. So the second row is dropped because there were 2 missing values. The third row is dropped because there are 3 missing values. The fourth row is not dropped because there is 1 missing value. Okay. All right. So that's how we are dropping rows. We're going to talk about columns as well in a moment. All right. Columns as well in a moment. Now let's see. I worked all on rows, but can I work on columns too? So we're gonna do that one too. So let's see. Let's remember df one more time. df1. Sorry. Okay. What I want to do is I'm just going to add one new column with all missing values. How can I do that? How can I add a new column? Remember that from our previous discussions. To this data frame, how can I add a new column? Anyone who would like to answer this question? How can I add a new column to my data frame? You can just type your code to chat if you like. How can you add a new column to df1? New column. Okay, Rajesh, thank you. So let's see if Rajesh's suggestion is going. So first of all, Rajesh says let's call the new column as new column. Okay. Thank you. Thank you, Ramia, Andrew. Thank you so much. So let's check your answers to in a moment. Okay. So let's call this new column as new column. That's what Rajesh is suggesting. And then in his suggestion, he says, let's assign NP and AN to this column. So when I do this, I'm going to create a new column, and all the rows in that column will be assigned with NP and AN. Let's see if that is going to work. F1. It works. So this is the new column, and it all has NANs. So let's see if there is any other. So let's add a fifth column. This time I'm going to follow Ramla's suggestion. So column name, let's call new 2. Okay, this is the column name. So this is the column name, and then again NP and AN. F1, of course. And then let's print the F1. And it worked, right? It worked. So it didn't work. So let's see what should we do here. Okay, let's see what should we do here. So here, the new 2 column, I assigned NP and AN, but somehow it didn't. But Ramla says, can you put this into brackets and then see if it's gonna work? Still, it didn't work. So what is wrong in here? So how can we fix this? Why this didn't work? What this works? So we can add a new column this way, but can we not add a new column this way? And Andrew is saying, can we add a column like this? df1 add. I never did this way before. Column. I think for this one, you might need to give all the values like NP. And let's see. I'm just curious if this is gonna work. I never do this way. Yeah. So there is no column. There is no attribute called column. Okay. So one maybe simpler way might be df1. I'm just going to say df1. I'm just gonna say, rather than saying here and new column, right? So yeah, exactly. So rather than saying new column, you can also give a number, right? So let's say I'm gonna say 5 because I have 0, 1, 2, 3, or let's say 4. Let's see what's going to happen now. It worked. Again, I gave the value 4, number 4, as index value to this new column, and then assigned all NP. So one thing I'm just curious is why this didn't work. Why this didn't work? Let's see if I don't. This works. I don't think this is gonna work. This is not going to add a new column. Maybe we can change the values of a current column, but this is not going to add a new column. Okay. Now, one thing, let's remember what we did. How can I get rid of these 2 new columns? How can I get rid of these 2 new columns? How can I, I'm going to use the keyword drop them. Yeah. So AS, yeah, that is correct. So the F1 new 2, that's what actually we did in here, right? So this one. Yeah, this exactly works, but this didn't work. That's what I wanted to emphasize. Okay. Now the question is, so we exactly did what you suggested. Yes. So df1 drop. Okay, let's drop these 2 columns. df1 dot drop. Should we use drop NA? So again, let's not worry about drop NA for now. Let's just drop these 2 columns. How can I drop these 2 columns from my data set? Yeah, run that probably dot notation, this dot notation. So I'm selecting, if I do this, I can select a current column, but this way I'm not able to add a new column. Okay. So I'm going to drop these 2 columns. How can I drop them? Don't worry about NA for now. Let's see, these are just 2 columns. I want to drop them. Remember from our previous discussions, right? So first of all, drop is a method. Inside this method, I'm gonna give the names of the columns that I want to drop, right? And then 4. And then let's see if this is gonna, by the way, new column is, put this inside a quotation. 4, I didn't put 4 into quotation. So let's see if this is gonna work. And then it gives me an error, not found in access. Remember last time we said we are gonna receive this error. This will happen all the time because we forgot to say something here. What is that? I need to tell, right, Python, when I drop from df1, where it should look for these index values. It should look for these index values as in the column indices, right here. It should look for these index values here at the top, not for the rows. If you don't say anything, by default, it is trying to find new column 4 in here. And that's why it throws an error. Okay, let's see. Now, as you see, I dropped those 2 columns. Now let's print df1 one more time on the screen. But I dropped them, but it's still here, right? Remember again from last time, if you want to drop them, then you need to say in, if you really want to drop them, right, from df1 and keep df1, I mean, make this permanent, right, on df1, then you have to say, make this, do this dropping thing, right, in place. So now we dropped those 2 columns. Okay, let's add these 2 columns one more time, okay? The 1 column one more time. So I'm gonna say, sorry, 4 equals np. Okay, let's see how df1 looks like. Perfect, okay. So that was what I was going to do, and then we just did it. So I added a new column with all n values, and then up to this point, we just tried our best to add and remove new columns, right? Okay, now the next question is, if that is my data frame, can I drop, rather than rows, can I drop columns? So far, we only dropped rows. Can I drop columns with missing values? Again, df1. This time, I'm not using drop. So because df1, I'm not using just drop. Because I want to drop columns with missing values. Okay. All right. So we already learned about drop NA. If I don't say anything here, it's going to drop the rows with all missing values. But if I say access is 1 and run this, so what happened is it dropped all the columns here, because here I said access equals 1, drop any column with at least 1 missing value. All the columns have missing values. So let's make this condition a little bit, put some condition here. So let me drop only the columns where all the rows in that column are missing values. Now I dropped, where is it? Yeah. Now I dropped the column where all the rows in that column are missing values, right? So try df column name equals name of list with values. Define list first. Yeah. So that will also work, Ramla. So that will also work. So you can add another column this way. You can give the values as a list, right? So, yeah, it will work. So you can give all the names as a list. So in that case, I wanted to show you that you can give a single value, and that single value will be copied to all the rows. That's what I wanted to emphasize. So now let's drop this new column here. Okay. And then let's make this. Okay, I need to take this. What happened here? Oh, yeah. again. I forgot access, right? Okay, so here is df1 one more time. All right, so we know now how to drop a column if that column has all missing values. Now the next question is, my next question, yeah, thank you, yes. Next question is, so we know how to drop NA, right? When we say x equals 1 and how equals O. Okay, we know that. Can you do this for me? This is an extra question, okay? Can you do this for me? Without using drop NA, can you drop this any column with all missing values? Can you do that? Is there any way we can do that? Can we drop the column with all missing values without using drop NA? Okay, let's think about it, okay? So let me write the question here. If you get the answer, please let me know. Here's the question. Can you drop any column with all missing values without using drop NA? You can use drop, okay? So let's see if anyone can find the answer for this. Let's continue. If you can find the answer, let me know. Okay. Now what I want to do is I want to drop a column if that column has a certain number of missing observations. That's what I want to do, okay? I want to drop a column if that column has certain number of, although sometimes we are collecting data sets. For example, I'm asking people, let's say, how old are you? Okay, what's your age? And then I see there are a lot of missing values in that column. So people don't want to say their age. So do you want to drop a column from your data set if that column has a certain fraction or certain number of missing values? Because I don't want to drop the rows if age is missing. In that case, if there are so many age values missing, I will be actually losing a lot of data set points. So rather than doing that, I just want to drop age column if age has a certain number of missing values. Okay, so that is the next thing we want to do. So for that, let's create another data frame. Okay, so for this data frame, I want to do something here. So again, it's not related to pandas. So from NumPy here, from NumPy, so there is a library called random. Okay, from random is allowing us to create random variables with different distributions. From random, I want to create random values using standard normal distribution. For those of us who are new into standard normal distribution, it means it's a normal distribution with mean 0 and standard deviation 1. Okay? Let me put this note in here. Okay, so I'm creating a standard normal distribution. So another thing here is, if I say 7, let's see what's going to happen. It is creating an array of 7 numbers, and all these guys are standard, has standard normal distribution. Most of them are going to be between -3 and 3, 99.9%. Okay, so if I do this, let me put this in a tuple. Then what I'm going to receive is, I'm going to receive a matrix. This matrix has 7 rows and 3 columns. There are 21 numbers here, and all of them are coming from this distribution. Okay, that's what I do. So I'm going to use this random number generator to create my data frame. Okay, so this is my data frame. So now df2 is this. Yeah, and Yeah, we are going to give it, I think during the break time or right after the break time, we are going to give information about the mentorship program. All right. So when I give break, when we come back from the break time, then we are going to give information about the mentorship program. All right. Please stay tuned and then you will receive the information. Okay. Thank you. So we just created a 7x3 matrix, and this matrix has all random numbers. Okay. Okay. This is not the point. I just wanted to show you that you can create matrices with random numbers. Now, what I want to do is I want to assign some missing values to some of the elements of this data frame. So let me see. How can I? So here is the question: assign NP NaN values to all rows up to row 4 in the second column. Can you do that? Can you assign NP and AN values to all rows up to row 4 in the second column? In other words, you're going to assign this guy, you're going to turn this guy into NaN, this guy into NaN, this guy into NaN, and this guy into NaN. Can you do that? Let me know if you. Yeah, Jose, I just saw your question. So there is no notebook that I shared. So I'm just typing the code. Just open a new notebook and then just type the code with me, please. So there is nothing that we shared. Okay. So how can we assign NPNAN values to all rows up to the 4th row in the second column? Again, this is my data frame. This is my data frame. I would like to assign NaN values to all rows, which is row 0, row 1, row 2, row 3, up to row 4 in the second column. So should I use, can I use lock, ilock? So which one I can use? So here, I think I can use any of them because 0, 1, 2, 3, 4 and 0, 1, 2, even if you use lock or ilock will be the same. So let's use ilock. Yeah. And then how can I select? So let me see. Okay. So up to the, so again, this comma means on the left-hand side, I have the rows. On the right-hand side, I have the columns. So I'm going to be assigning from row 0 up to row 4. From row 0, I'm writing things all explicit here with steps of 1 up to row 4. So this is the first row. This is the last row, which is not included. And this is step size. So row 0, then step size 1, then row 1, then row 2, then row 3, index number 3, and 4 is not included. Okay. And then these rows will be receiving NP and AN values for the second column. What is the index of the second column? 1. So if I do this, so what happened here? Why it is only giving me this one? I mean, there's negative 0. Why it is only giving me this first value? Any ideas? What happens if I do this? Right. So what I did is earlier I was trying to imitate the what is that? NPNAN. It didn't work. So what I did is from the first row up to the 4th row, which is not included, and in the second column, I pick these 4 values. Okay, these 4 values. Now I'm going to change them into NaN. Okay, let's see what happened to my DF2. Okay, so I changed these guys into NaN. Now we know how to do it. So the next question is assign, again, NPNAN to all rows up to second row in the 3rd column. Okay, so let's do, now we know how to do this, DF2, right? All rows up the second row. I mean, let's call this row index 2. So that's very explicit. So row index 2, index 2. So up to index 2, comma, third column, 0, 1, 2. Equals, again, df2. What? Okay. So now I have some NaN values. That's what I was trying to do here. Okay. Now let us drop all the missing values from here. df2 drop Na. Okay. If I say drop Na, it is going to drop all the rows with at least one missing values. Now you can see that I'm only going to have these 3. Let's see. Exactly, right? The last 3 rows are the only ones which remain. Now, the next question is, I want to drop any row with at least 2 missing values. That is a threshold. In that case, this guy will be dropped, this guy will be dropped, but the others will be remaining, right? Exactly. Okay. Now, what I want to do is, rather than dropping, can I replace them? Okay, that is the next question. Rather than dropping them, can I replace them? So again, let me take my data frame. Can I replace these missing values with some value? Okay, fill NA, fill all the NA values with 0. So let's see what happens. Didn't happen. So what happened here? Why I didn't have 0 value assigned to missing values? Why do you think so? I was expecting that df2 would have all missing values. So if I don't do this, you see, if, my original data frame did not change. Don't be confused, please. I believe that was there last week, trying to modify the slice of the data when using Usman. Yes, exactly. That was the mistake. We just fixed it, right? We just fixed it. Now, my next question is, this is again, this I receive, and then sometimes I receive these questions. When I say fill NA 0, I see that NAs are turned into 0. But again, when I print my data frame, my original data frame did not change. So now let me see how my data frame looks like. Now NAs are changed into 0. Yeah, in place equals 0. Jin Huang, thank you. Exactly. So that's how the change we are making will be permanent on our original data set. Okay. Now, next question. Okay, I'm just asking some questions today. Can you replace 0 values in df2 with 9? I just filled the missing values with 0, but now there isn't any missing value. I cannot use fill NA anymore. Can you replace all 0 values with 9? So how can I choose which values in my data frame are equal to 9? So if I do this, do you think this is going to work? So let's start from here. Again, we did this last time, but I'm just trying to remind you guys. If I say df2 double equal 9, right? I'm using a condition here. I'm saying if any element of df2 is 9, give me true. I'm sorry, not 9, 0. If anything is 0, give me true. Otherwise, false, right? So here I only see Boolean values true if that element is equal to 0. Now, if I say df2, so I'm using this Boolean matrix to filter my data frame. But let's see what happens. Remember from our last discussion, let's see what happens. You see, I am not actually removing anything from my data frame here. I'm only viewing the parts of my data frame where the value is equal to 0. For all the other values which are not 0, I'm seeing NaN. This doesn't mean that that value there is NaN. It means That value here is not satisfying this condition, that's all. Okay. Now, if I make this equal to 9, so don't expect, I'm not expecting, but let's see what's going to happen. I'm not expecting that this 9 is going to be assigned to these NaN values. I'm expecting this 9 be assigned to these 0 values. Let's see what happens. Exactly, right? So I replaced zeros with 9. The other values did not change. Okay, so this is something that we should keep in mind. Okay, again, from time to time, we get confused with that. Okay, now what I want to do is, let me go back to my original data frame. Okay, my original data frame. And let me assign the NaN values one more time. Please do so. I'm just assigning the NaN values one more time, okay? So now I'm coming back here, df2. Here is my original data frame with missing values. Okay, one more time. Let's fill these missing values with 0. Okay, let's remember this, 0. And then if you want this to happen in place, use in place equals true. And this is my data frame. All right. And then we also talked about how we can replace zeros with 9. Okay, now one more thing. One more thing. Can I use fill NA? Can I use fill NA for, different values too? Can I do that? For example, can I say, here is the question. Let me go back to my, sorry about that. My question. Okay, the missing value. So what I want to do is I want to assign different values to column 1 and different values to column 2. I don't want to fill everything with 0. I want to assign different values to column 1 and another set of different values for column 2. How can I do that? After this, I'm going to give a break, okay? And then when you come back, we are going to receive some information about the mentorship program first, and then we are going to continue with our session. So what I want to do is I would like to fill NAs this time selectively, right? I want to assign different values to the second column and some other value to the third column. For that, I'm going to use a dictionary. And I will say this one here, this is the index of the column. It's the name of the column. That's the name of the column. What is this column? Column 1. It's not column, the second column, it's column 1. So I want to change this column to 0.5 values. And I'm going to change this column 2 to say 0. Okay, and then I want this happening. Let's see. This is df2. Okay, perfect. Exactly I was expecting, right? So the second column is changed all into 0.5. The third column, NA values changed into all values 0. Okay. So Randa, yeah, we can also use update method. So if you could give me an example with update method, I'm going to write your code and then see how it works. Okay. I don't use update method that often. I know that we can use it. So if you could please just post a little example so we can use it here and then share with everyone else. Okay, so it is 10:57. Let's take a short break. 10:57. Let's come back at 11:05, please. All right.
Dr. Jaran, I will give a short announcement before people taking a break.
Sure, go ahead, please.
Asking about our mentorship program. I will explain briefly, and then we've given a link for some information on our info session. So I will just share screen a little bit, and let me do that. Okay. So you will still get questions about our mentorship program. And then technically our mentorship/internship program is for people who's been studying data science and have a struggle to find a job because of those challenges. gaps in real world project applications. Because there's so many companies asking that if you have done any real world application other than small data science projects. And then lack of experience is associated with it, because unfortunately demand is high, although supply is high, but people look for experienced people. So we try to bridge that gap. And then limited mentorship, where so many people take classes, take programs, boot camps, but they have they don't have a much mentorship in these programs. So what we really provide in our boot camps, we highlight those. We provide real world projects that we partner with the companies in Silicon Valley at different levels. And we provide so many mentors, 5+ mentors in different projects, every mentor expert in their own field. And then our companies are in Silicon Valley. We are in Silicon Valley, we give that exposure. One of the other important highlights is our mentors and instructors are both from academia and industry. So I myself, I work at Stanford, Dr. Geran, and San Jose State University, prior to KAIST and Santa Clara University. And our mentors, some of them from Google, Facebook, and other promising companies in Silicon Valley. So overall, what we have projects, we have mentors from top companies. We provide practice interviews. We provide career coaches and interview coaches, resume support. We give a full package for people. It's main program in 15 weeks. People are in borderline to getting qualified for program. We might offer them 2 months extra, and so they can be full ready for the market. So there is a full information links we shared. If you have any questions, you can just look at, just also talk to us. We schedule like 15 minutes interviews to understand your background. So it's the application process. If you're qualified and you get we can accept the program. Yeah, hope if you have any questions, you can let us know. Thank you for listening. Hope that you can enjoy the rest of the session.
Thank you, Dr. Wai. Okay, everyone. So let's get back. Let's be back at 11:05. Again, if you have any questions about this program, let us know, and then they are going to get back to you. Okay. Yeah, the recordings are being shared, Jaita, and then I also shared this file with you guys. So again, I'm gonna share the link to previous week's material, and I'm gonna put this one into this week's material. I will share with you. Yeah, let's continue. I was just I just remembered a project we worked on maybe last year. For example, just want to give an example on what kind of problems you might be dealing with, and then how Pandas will help. It's gonna be extremely helpful actually. Let's say you have a data set, okay, a data set. This data set has customer IDs, okay, customer IDs, and then the email IDs, okay, IDs. All right, so customers are receiving emails and then dates. So what happens is you have a data set. In this data set, which customer received what email on what day? Okay, so it's a very simple thing. There are only 3 things in this data set. Now, from this data set, can you, and then the dates are, let's say, from, I'm just making up 2021 to 2023. Okay, 2021 January to 2023 December. So can you create a data set where I can see on any date which customer had received how many emails up to that date? So that date. Okay, so again, if based on what we learned so far, maybe the only thing I think missing here is we didn't deal with dates. That's gonna come later. But here, what you have is you only have email IDs and dates. For example, customer ID 0, customer 0. She received email 01 on January 21, okay, and then email ID 13 on June 22, okay. So for this customer, what I want to see is, let's say I give you a date, for example, what is that? On January 5, okay, January 5, and on June 7th. Okay, so she received the first email on January 5, 21, the second email with ID 13 on June 7, 22. So then January 1st, 2021, customer 0 did not receive any email, right? And then, but on January 6, 2021, customer 0 so far up to this date received 1 email. One email and an email. And again, you can continue this as June 8th, right? June 8th, 2022, customer 0 received 2 emails. So on any date, I want to know which customer received how many emails up to that date. So this is an email campaign. We are just trying to see what is the impact of number of emails customer is receiving, right, on the sales. So that I need to know how many emails the customer is. You can make this data set even more complicated. So let's say we can have a window, that window is shifting, and within that window, how many emails that customer is. For example, on any date in the last 2 months, how many emails this customer received. So that's another thing you can do, right? So to be able to create such data sets, okay, we need to be very, very comfortable with Pandas. So that's the point of these sessions, all right? Okay, let's continue then. Another thing we can do is we were talking about filling in missing values. Again, we have to. So if you are using sklearn, again, those of us who are familiar with machine learning, sklearn library, open source library, we are dealing with missing values in a different way. So we can use some functions, some methods, actually, classes available from sklearn, right? So imputer. So we can use simple imputer, for example. So here is my data set. Say the data set, and then I'm gonna be imputing this data set with mean. So what does that mean? So impute any missing value. The usage is a little bit different, but I'm just giving you the idea. Impute any missing value, any numerical column which has missing values, impute those missing values strategy with the mean of that column. So this is how we impute using sklearn. Okay, imputing means filling in missing values. But this is, we are using here a already available class. Okay, we have to import it. Now the question is, can you write the code for this? Can you fill in missing values with the column, with the mean of that column? Okay, so let's begin with series first. Let's begin with a series first. Again, pd.series. And this is the array. Let's say 1. Here is the missing value. 3.5. Here is another missing value. And 7. Okay, so let's call this series 1. S1. So what I want to do is I would like to fill in this missing value. Okay, so remember, I can fill this with 0, but I'm not going to do that. I'm going to fill in with the mean of this series. So let's first find the mean. This number. So when you find the mean, okay, this function mean, method mean, when it finds the mean, so let's see how it is, how we are finding the mean. So these are important details, guys. So when I find the mean of this data set, am I adding up all the numbers except the missing values and dividing it by number of numbers? Okay, or I'm just adding up numbers and dividing them by number of non-missing values. Okay, so these are two different. Here I have 5 entries, 2 of them are missing, and then there are 3 valid numbers. When I add these guys up, it's 10.5, 11.5, right? 11.5. Am I dividing 11.5 by 5 or by 3? So apparently it is divided by 3. So please keep in mind, when you're finding mean of a column, if that column has missing values, the mean is found based on non-missing values. And when you find the mean, then the denominator of that fraction, that denominator is number of non-missing values, not all the data points. Please keep that in mind. Okay. Now I'm going to find this mean and then fill all the missing values with that mean value. Here's what happens. So this is one way of filling in missing values. So there are so many different ways, more complicated ways, but this is a very simple way. I'm filling in missing values with the mean of that column. Okay. So now let's do the same thing. Okay, let's do the same. Can we do the same thing with what is it? For data frames. I'm just curious. Let's see if we can do this with the data frames. Let's see where is our data frame. df2. So these are the missing values. Now I'm gonna fill this up. Fill the missing values up with mean. So remember the first column I said earlier. Where is it? First column 0.5. So let's see if we can do this like that. First column, okay, comma. That's the first column, and then it's the second column, column 2. The first column, what I want to do is I would like to pick the first column and take its mean. Similarly, I would like to pick the second column and take its mean. So for that, first of all, let's see if this works. I don't have this in my notes. I just made it up now. So let's see if it works. It works, right? This is the mean of these 3 numbers. And this is the mean of these 3 numbers. Now let's see if df2 will be replaced, the missing values will be replaced by these mean values. Yes. So this is one way of filling in missing values. Another thing that we already learned. Again, let's say df2. So what I want to do is I would like to fill in missing values. So for that, I'm gonna let me create a different data frame because this is going to be, what is it? I'm gonna use forward filling. So Actually, I can use backfilling. Okay, let me use backfilling here. So the same thing. Let me change this first missing value with some number. Okay. So how can I change this first missing value with a number? Can I choose this? 0 and then 1. Can I assign it to, I don't know, 2.1? Let's see. It works, right? So I assigned 2.1 to this missing value. Okay, there is a reason why I just did that. So what I'm gonna do is I'm gonna take my data frame. Again, going back to the example I gave you earlier. Look, in this example, remember this example, customer ID, email ID, dates. Now, if you think about this example, let's imagine there is a table. In that table, I have dates. Okay, I have dates. I have customer ID. And I have email ID. Okay, customer ID. Now, all the dates begin with, let's say, because it's between January 1st, 2021. January 1st, 2021. Okay, for all the customers. So this is only one customer. This is only one customer. Which customer? Customer ID, where is that? 0. Okay, this is customer 0. Did she receive any email? No. Okay, this is January 1. This is NAM. Or let's call it none. Okay. Now, this customer did not receive any email, right? So in my data set, I only have the record for each customer when they received an email. That means this customer received an email on January 5th. Okay. She received an email at January 5th. And what is the email ID? It is 01. This is the email ID, 01. Okay. So she didn't receive anything on January 4th. She didn't receive anything on January 3rd, January 2nd. Okay. So what I want to do is, if she did not receive any email, I can use none, or I can use a code for that. I can use a code for that. I can use a code 0, or I can use none. So I would like to create data for like January 1, 2021, customer 0, none. Okay. And then January 2, customer 0, none. January 3, customer 0, none. So what you're gonna do is you are going to actually add some data points here, which you don't have in your original data. And then, by the way, for January 6, 2021, customer did not receive any email on January 6. So what is the total number of emails she received? It's gonna be still, so the only email she received by now is, she didn't receive anything. She didn't receive anything. And then I'm gonna add another column here, cumulative sum of emails. So she did not receive anything here, 0. She did not receive, she received 1 email here, 1. And here she didn't receive any email, but by now she received only 1 email. Okay, so I'm just creating this data set. Right? So you need to fill in some dates here. So for example, this date was not there in my original data set. I need to create this row for this customer. I'm gonna do the same thing for other customers. Anyways, so let's come back here. From time to time, we may need to fill in missing values with previous values. Like here, I know this cumulative sum, but like here, it is 1. Here, there isn't any email received, so this is supposed to be 1 as well. It has to be the same with the previous value. Okay. All right. So when I want to fill in the missing values here, I would like to assign the previous value. How can I do that? So what I'm going to do is I'm going to fill in missing values. Okay. With what? We did this last time, if you remember, with the previous value. Let's see what happens now. You see, for the second column, 2.1 is assigned to the next, and then the next, and then the next missing values here. But this guy, because there isn't any valid value before this guy, this guy has no chance, right? So it's still missing. So for this one, can I use the previous value? Yeah, we can do that too. This time, the second column will be having missing values. Let's see. And rather than forward filling, I can do backward. Okay. So this time, what I'm doing is, let's remember how our DF tool looks like. DF2. Okay. So this time, the second column, 2.1 is not going to be assigned. Rather, 0.17 is going to be assigned. That's what happened here. Again, these two guys, this time they are not missing because they have a non-missing value after some time, right? So 0.25, negative 0.25 is assigned to it. I'm filling for the missing values backwards. So just keep this in mind. It's going to be very, very useful when you want to fill in missing values, especially for time series data sets. Another thing we can do is, well, I don't want to fill in all the missing values with the same value. So for example, if this was a time series data set, and then let's say that I'm referring to another project, this is number of requests for Uber requests. So you are developing an application, you're trying to predict at any point in time in San Francisco area, right? What is the probability that Uber driver is going to receive a request, right? So for that, maybe these time points can be like every 10 minutes or every 30 minutes. In that case, if you have some value for that time, after 30 minutes, you may assume that the conditions did not change that much. After 60 minutes, you may assume the conditions did not change that much, but after 90 minutes, you might say the conditions change. For example, traffic is changed, right? So something has happened. So in 90 minutes, it's a long interval, right? So I'm not going to assume that 0 and then 90 minutes, the conditions are the same. So for that, you may put a limit on how many subsequent missing values will be replaced with this original non-missing value. For that, what we can do is df2.fill_na. Again, method. Let's say forward fill. Remember, this is on my original data set, and then I will only replace them up to 2 missing values. Okay, let's see what happens now. Now you see 2.1 was not missing. The next 2 missing values are replaced with 2.1, but not the third one. Because the third one, again, depending on the context, I was just trying to give you an example. Depending on the context, you might say that the correlation between 0, 1, and 2 is still high, but the correlation between 0 and 3 is not that high. Then I'm not going to copy the value from 0 to row 3, right? So you can make that assumption. Okay, so let's continue. Please let me know if you guys have any questions or anything you would like to add, right? Feel free. So what I'm going to do next is, again, let's create a data frame first. And then this time we are going to see, what if we have duplicated values in our data frame? What are we going to do about that? Okay, so this is the next thing, which happens a lot. Okay, which happens a lot. So let's create a data frame. Again, when I create a data frame, I generally use dictionaries. It's much easier for me to, see what's happening. So this is 1, 2. So K1 is the key value. 1 and 2 are the values. So if I do this is Python, right? So what I'm doing is I am multiplying this by 3 means I create 3 copies of this. So if I run this is what you see. 1, 2, 1, 2, 1, 2. There are 3 of them. Okay. And then let's have another, what is it? Another one. Okay, another one. So I'm going to show you one thing actually after this one. Let's say this is K2. 1, 1, 2, 3, 4. Okay. All right. So this is my data frame. What I want to do is say 1, 2, 1, 2, 1, 2. It's 3 times, but let's say the last one is going to be 2. It's not 1, 2, right? 1, 2, 1, 2, 1, 2. That's why I multiplied by 3. And the last one is going to be 2. How can I do that? So what you can do is you can simply come here and say plus, because this is a list, right? 2. And then let's put another value here. Again, these are simple details, but it's going to be very useful for us to know, right? So now 1, 2, 1, 2, 1, 2, and the last one is this guy. This guy here, and this is the value for it. Okay, all right. Now, as you see in this data frame, there are some rows which are replicated, right? So like this one. Actually, it's the only one. These two are replicated. There are, for example, I mean, 1s and 2s are replicated. 1, 1, and then 3, 3, and 4, 4 are replicated. But the whole row is replicated twice. So if I say data, let's assign this df3. And then df3, let's see df3. And then df3 dot duplicated. Okay. So what it says is it is checking if the entire row is duplicated. So the first row, there is only one. There is only one of this row. So that's why it is not duplicated. I know 1 is duplicated. I know string 1 is also duplicated, but this whole row is not duplicated, right? Here, there are 2 rows duplicated, 5 and 6. So this 2, 4, right? 2, 4 is duplicated. So this guy is a duplicate. This guy is a duplicate. Okay, this guy is a duplicate. So it's not saying duplicated to both of them. This guy is a duplicate. That's another. Okay. How can we do this fill with limit for a large data set? For a large data set means when you have, okay, I'm trying to answer this question, Rajesh. So when you are saying, I mean, it's gonna work for large or small data set the same, but what are you saying about? So when you say large data set, what is your limitation? So, I mean, if you can talk a little bit more about what makes you think that it's gonna be different when you apply fill for large data set, then maybe we can think about it. Because it's gonna be working the same for small or large data set, but then there might be things like, I want to use this method, for example, for only customer 1. Can I do that? Yeah, you can do that. For a large data set, you can filter data set first and then apply backfill or forward fill for only that filtered portion of your data set. That you can do. Okay, let's get back to the duplicates here. Look, I was just trying to say these 5 and 6 are the same. 6, the first one is not duplicate. The second one is duplicate of the first one. So please keep that in mind, okay? All right, okay. So next what I'm gonna do is I want to drop the duplicates. Okay, I want to drop the duplicates. But before then, can we check duplicates for a certain column? Okay, so let's do that. df3, I want to check if df3 is duplicated for a certain column. I can create a subset. Now this subset can be a number of columns. In this case, I want to pick first column, let's say. Okay, now let's see. Look, 1 is duplicated many times, right? But the first time 1 occurs, it is not a duplicate. The first time 2 occurs, it's not a duplicate. But the second time 1 occurs, it's a duplicate. And 2 is occurring second. So as you see, the rest is all true because they are all duplicates. The first occurrence of any record is not duplicates. Second and third and fourth are all duplicates. Okay. So here I didn't say anything about subsets. So we are looking at the entire column, entire row. Here I am only looking at the first column. So I can add the second column. This will be the same thing as if I'm looking at the entire row, right? Same thing, right? See this is same with this one. Here subset, I'm checking both columns together. Okay, next. If my data set has duplicates, can I drop these duplicates? DF3, of course, drop duplicates. When you drop duplicates, in this case, if you don't say anything, by default, it is going to drop any duplicates after the first occurrence. Okay. So as you see, the last row, which was the duplicate, is dropped. But again, keep in mind, your original data set is still the same. Okay, it's still the same. If you want to do this, then in place, sure. Now your DF3 changed. Okay. So let me bring my DF3 one more time. I'm just running this guy one more time. Okay, this is my original DF3 now. Okay. Now what I want to do is I'm going to add one more row column to my data set. Okay, so let's edit DF3. Now we know how to add a new column, right? Say B1. And if you just do this, look. Again, remember, I assigned the same value for all the rows in that column. I'm not going to do that. I'm going to assign from numbers from 0 to 7. 7 is not included. Okay, so here, 0, 1, 2, 3. Okay, good. Again, I can drop the duplicates based on a subset. So let's see. I'm going to take my DF3. I will drop duplicates, duplicates based on a subset, which is K1. K1. Okay. So what I did is from this data frame, all the duplicates that occur on K1 are dropped. Okay, same thing. One. If you like, remember I dropped 6-1. If you want to keep this guy but drop the first one, that also is possible. What you can do is we can say keep the last one. Now I have, this is the last one. This is the first one, second one, the last one. So I kept the 4th row. And also I kept the 6th row because this is the last 2 out of all occurrence of 2. Okay. So why last time? Again, going back to same, I used all this in this project. That's why I keep remembering that project. For example, here, let's go back to this example again. You are counting number of emails a customer received, and then you want to create another data set. You can create another data set. That's okay. In this data set, you will have customer ID and number of emails this customer received. Of course, you can solve this problem with the original data set very easily. So you just group your data by customer ID and count email IDs. That's it, right? We're gonna learn about group by, okay? And it's very easy. But let's say you are given this data set. You are given this data set, and then what you want to do is it's not just the number of emails. It's just what you want to do is for each customer. I mean, customer receipt has 1 email and then 2 emails and then 3 emails, right? So here, if customer has only 1 email, received 1 email, and then nothing happened in the next month, okay? Then all the next month customer received only 1 email, 1 email, 1 email. It is repeating, right? So what you can, if you want to know the number of emails customer received with the last day before the next email is coming, right? Then what you can do is you can drop duplicates for each customer and keep the last data point. The last data point will be number of emails that customer received up to that point before the next email arrives. And I'm repeating, create a data set that will list the number of emails that customer received before the next email arrives. Okay, so again, from this data set, it's very easy. You can simply, so let's say in this case, how can you say, let's say this is your data. You are going to say drop duplicates, and then you need to create a subset, right? What is the subset? Based on, the subset will be based on customer ID, and then, not email added, cumulative customer, sum email, right? So what you're gonna do is, this cum sum email is going to be repeating for the same customer until she receives the next email. Let's say the next email is coming 3 days later. Until 3 days later, total number of emails that customer received remains the same. So that way, that customer ID and cumulative sum of emails will be repeating, okay, over and over again. So that's why I'm using this as a subset. I'm gonna drop duplicates based on these two, okay, all right, and then I will keep the last. So what happens is, now I know how many emails a customer received up to that day before the next email arrives. Okay? So this is exactly going to give me that information. All right, let's go back here. Another thing we can do is we can use map function. So that's another thing that I would like to introduce. So for that, I'm going to, I'm not going to type the code. So if I can copy from, actually, I'm going to type it and then I will share it with you. That's going to be easier. The form. Again, this is a data frame. Okay, and then this is a dictionary. So it's going to be full. No meat, so sorry about that. If you are vegetarian, okay. This is how the data set is, okay. Okay, so this is the data set. And then I also have, the ounces. I'm just going to make it up, okay. 6, 7.5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, I think we are fine. Let's see. All right. It's very hard to type. I'm gonna share this from the chats for you so you don't have to type it. Okay, so you can have to type it. All right, let's continue. So what's gonna happen is, let's say I want to add a column. So this is DF4. I want to add a new column, and this new column is going to tell me what each food is made of, what animal is used for this food. Okay, so for that, I'm gonna create a new dictionary. Okay. All right. In this dictionary, I will say bacon is made of pork. Okay. And then pastrami is made of cow. So let's use this one. I should have used a different example. Sorry. I just use from the textbook, okay? And B. Then okay, let's say this is the dictionary. What we want to do is we want to create a new column, and this new column is going to map each food to the corresponding animals of the same. So for that, we are going to do a very simple thing. We are going to choose our data frame. From our data frame, I'm going to choose the column food. And then this column, I'm going to map that column. When I say map, this map function is going to run on each value of that column. Okay, it's going to say take bacon. Okay, and then it's going to take that bacon and then it's going to map it using this dictionary. So bacon is going to find bacon keyword and put the value for bacon as the value for the new column. Okay, so let's do this. Meat to, and of course, this is going to be the new column. Okay, let's see how the F4 is now changed. So what is the mistake here? I shouldn't use curly brackets, right? Because map is a function. Okay, now as you see, I created a new column, which is mapping each entry in the food column to its corresponding value. So this is not, again, we can have different examples. For example, I can give you a data frame. In that data frame, you can have, what is it? Cities. And then I can have each city is what state, right? And then I can have a new state column. So I can map each state to its corresponding state. Another thing you can use is, we're going to learn about it later, but for example, you can have a categorical variable here, and each category can be mapped to a certain number. For example, man 0, female 1, for example. You can create a new column, and then you can map each category to its corresponding numerical number. Okay? Again, we don't have to do it that way, but this is one way of doing that. Right? So that's another very useful function in usage of function on Pandas data frames. So we can also do the same thing, passing a function to map. Okay, so let's see. For example, I want to define a function. That function is having x as the parameter. And then what this function returns is, given x, I'm going to take this dictionary, meat to animal. Okay, I'm going to take this dictionary. If I know x, x will be the keyword. If I put keyword into dictionary, so let me show you what it means. For example, meat to animal, right? So I'm going to say, should be square bracket, by the way. What is that? Pastrami. So when I run this, I get cow, okay? Pastrami corresponds to cow. So this should be, oh. So I can create a new function like that. And then again, I can do the same thing. So df4, let's say animal 2. Okay, I'm going to use map. Again, rather than putting the dictionary directly, I can put this function here, get animal. It doesn't work. I need to put the, sorry, need to put the food and then say df4 animal to. Okay, let's see df4. Now I have a new column, animal 2, I mistyped, which in this case, again, I'm using map function, something that we need to be paying attention to. Get animal is a function. Remember, when we call a function, for example, here, when I call get animal function, okay, the parameter for that function is a string, right? So pastrami. When I run this, it's going to give me the cow. But when I call this function using map, I am not doing this. I'm not doing this. It's going to give me an error. Because if I do this, it requires a parameter, positional argument, the parameter value, right? Positional argument. So what is x in here? I don't need to put x in here because this function is going to get the positional parameter value from this column as we move from one row to another. Okay, so please keep that in mind. All right. Yeah, David, I'm going to show one more. Let's go through one more time. So can you please show what is meat to animal? This one. This one. Okay, so let me copy this and then share with you. This is a dictionary. This is a dictionary. This is a dictionary where it is mapping a keyword, which is the food, to the animal that it is made of. Okay, so that's a dictionary. So what I was trying to say is, if you like, you can apply map function. And by the way, I also used apply words because we are going to learn about it as well. You can either use map or apply. We can do both. So you can use map function and put the dictionary as a parameter for that map function. This will work. So what happens is this map function is going to be executed for each entry of the food column. So for example, map is going to map bacon to its corresponding value. Map will again map pastrami to its corresponding value. So this entry for map is a dictionary. Okay. Jing, you can also use join function, but you need to turn meat to animal into a data frame first, and then you can use join function. Yeah, you can use join. We are going to learn join function next week. Okay, so you can turn meat to animal into what is that? Data frame, and then use join function. So this is one way map. Another way is rather than passing the dictionary as a parameter for map, you can pass a function to map. Okay, that's the next thing. You're welcome, David. So we created the function first. Here, this is what I was trying to point out, and so I see this is sometimes a confusion point. So this function is taking a parameter, right? X. And then I'm using X as the keyword to my dictionary meat to animal. So, and then what this function is returning is the value for that keyword. But when I call that function using map, I'm not doing this. Okay, I just put the name of the function. That's all. So what it does is, what map does is, map takes the value, this one, takes this value, passes this value as a parameter to this function, and that function returns the corresponding animal, okay, for that food. So that is the distinction. So that's what I was trying to emphasize, right? Okay, let's continue. We can also use, so today we spent time on, what is it, fill NA. This will be the last thing, then I will stop, okay? I will stop, and then we are going to continue next week. Again, can we also use apply? Yeah, Rajesh. So that's what I was saying. We're gonna learn about apply. You can also use apply. You can also use apply. So let's do it. Let's do it. Let's do it quickly. We have 4. So I'm gonna copy this. And after this, let me stop, okay? Animal 3, I know that you guys are tired. Animal 3, I'm tired. And then rather than map, let's use apply. And then let's see what happens. Yeah. Okay. This also works. Apply also works. Map works. Apply also works. Okay. But we are going to learn a little bit more about apply, hopefully next week. So in our next meeting, let me see. Let me just looking at my notes. We are going to learn about, apply. Again, do some work on indices, renaming, and then creating bins for histograms, okay, which is very important. So if I give you, for example, ounces, this one, it's the ounces, it's a continuous variable. So in machine learning, when you are training data sets, you are going to be working with continuous versus discrete variables. Continuous means numerical most of the time. I mean, most of the numerical ones are continuous, not the other way, okay? Discrete means categorical. But sometimes categorical. Sometimes you may do the following. You can, for example, age. There is a column called age, 20. These are the age of people, 49, 30, okay, blah, blah, and 45. So what you're gonna do is, rather than using age, can I bin age into groups like following? So for example, young, okay, mid-age, senior, okay? So young will be less than, let's make this, let's make people happy a little bit, okay, 45, all right? So mid-age is going to be between 45 and then, okay, 65, all right? And then senior will be, let's say, greater than 65, right? If that is the case, what I'm gonna do is, rather than using the numerical values of age, I'm gonna use the group names, the categories. So how can I turn a continuous variable into a categorical variable this way? Okay, so that's what we're gonna learn in our next meeting. And then again, we are going to how we can join multiple data frames. Once we learn this, then I'm going to share with you guys some questions, some interview questions. Because once you learn join, then you can join data frames, run some conditions on them, and filter them. For example, there is one data frame which has only email IDs, and that's exactly what I tried to describe earlier. And there is another email, it's giving me customer purchase history. So then I want to create one single data frame from these two. First, I'm going to do some work on one data set, trying to find what is the number of emails, cumulative number of emails a customer received. On this other side, I'm going to do some work on, I'm going to take care of all missing values and everything. And then I will join these two and then create a new data frame, which is going to give me customer ID, cumulative number of emails the customer received up to that date, and then cumulative amount of purchases the customer made up to that date. So that I'm trying to figure out what is the impact of number of emails on a person's purchase history. Okay, let's say that's what you are studying. So when we learn about how we join multiple data frames, it's going to be a lot more interesting. And then hopefully, if we have time, we're going to talk about group by. That will actually, after this one, they are going to almost be able to solve any problem that we can solve with SQL. Again, I'm not talking about performance. In terms of filtering data sets, aggregating data sets, once we also learn about group by, then I think we can solve any problem that we can solve with SQL. We can create, when I say any problem with SQL means in terms of filtering and aggregating data set, then we can do the same things with Pandas. Actually, for some, I know Amazon during the interviews, if they're hiring you as a data scientist, in addition to SQL, they also want you to do the same kind of operations on the data set using Pandas methods, for example. So can you do the same thing with SQL and Pandas methods? Okay, I'm stopping here. Thank you so much for listening and staying until the end. So we're gonna meet again at the same time next week. Okay, so until then, please take care and then come back next week. I'll be here. Thank you.